Hi, Louie. Okay, here's problem one. When it says find the solution to the differential equation, literally that means what is the equation for which this guy is a derivative? Because here's dy dx, blah, blah, blah. So find the solution means what's the original equation? So we just separated the dx and then took the integral of both sides. Cool, so we get this intermediate. Yep, so now we want to plug in this value because we're not actually solved because we still have this plus c. Let's go ahead and plug in. So we know that y equals 2 when x equals -1 cubed minus 2. Just get c by itself. Solve for it. So equals 2 equals -1 plus 2 plus c. So 1 plus -1 plus 2 is 1. 2 equals 1 plus c. Good job. Yes, c equals 1. So plug it back in for c right here. We get y is equal to x cubed minus 2x plus 1. Oh my god. Plus 1. Haha. Solid. Okay, now draw a slope field for this.
What's 3 times 4?
12. Draw a slope field. So remember, dy dx, keep in mind it's equal to 3x squared minus 2.
How do you do the ones on the ends? Because that's like 10.
And it's almost straight up. That's literally going to be the slope, and so it's going to be almost straight up. So it's going to look like...
So it doesn't have to be accurate there.
It's going to look like that.
Yeah, okay, that's basically what I'm doing.
Oh god, if I could just do it the same angle every time.
No, that's impossible. Even when you see it, even if it's like a slope of 1, it's still impossible. I still get it wrong every time.
I feel like I should have a different line that's something that's not yellow.
No, that's fine. It's just, there's no way to, I wish it was just easier to just like do a little label for everyone, like what is the slope you're trying to make it look like.
Funny.
I know, right?
I don't listen to what you're saying.
Good.
But now we have to graph the original one. I don't know how to graph parabolas.
Are you saying that?
Do you know how I'm getting all of these numbers?
Are you saying that it's the same thing every x number?
For a certain x, for a given x, it's the same all the way vertically.
Why?
Because if I plug in for, let's say, -2, 3 times -2 squared minus 2. So that's 4 times 3 is 12, minus 2 is 10. So all of these right here have a slope of 10. Because all of these have the same x value. So this is a slope of 10, 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 because it's the same x value all the way down.
Oh, because it was, okay, that makes sense.
So I put in a -1. Oh, well, this is a slope of 1. So this is a slope of 1 all the way down.
I thought it was a slope of 3. Oh, because
3 minus 2. Yep.
Oh,
And it's a slope of -2 all the way down. Of course, you're not actually writing the numbers when you like draw it, but just to be thorough. Let's see. So -1 and +1, since this guy is squared, they'll have the same slope. So this guy is super high. Not doing a very good job drawing it, but you see the general gist. So we need to support our answer for number 1 by overlaying our solution on the slope field we created. Okay, well, we know at -1 we have a value of 2. So at -1 we have a value of 2, which is right here. So you just kind of have to like plot a couple points. How would you try to plot it? So number 3, how do we know where to draw?
Well, we have it starts at 1 wait, it's y1 at x0 because it's vertical.
Y1 and x0. Oh, yeah, right here. Cool. Yep, because if x is equal to 0,
Oh,
you just have this.
all the points because I
You have to draw. You have to draw the
I draw it through
equation.
the slope field.
Yeah, so it's gonna look like this.
Yeah, I did something like that. That's cool.
Yep, that's how it should be.
Okay.
Why would it be when x is 0? Why would y be 1?
Y equals 0 cubed minus 2 times 0 plus 1. Y equals 1 when x is 0.
So what are we factoring into?
What do you mean? I'm sorry, I'm putting this equation onto the field because it says
I thought we
overlay your solution, aka the original equation line graph.
I thought it was saying plot the dy dx.
Oh, well, so we did. Number 2 is the slope field. Number 3 says, like,
You know,
draw the line.
I totally forgot the unit circle until like yesterday. Like, I had to help someone,
Ooh.
and I didn't remember it.
You weren't given the unit circle in your test in pre-cal, were you?
No.
That's what I thought. All right. Let's hit some U substitution. Okay. So we have secant squared of 2x minus 1 dx. Bradley, what do you think we should let U equal?
2x minus 1.
2x minus 1. Am I going too slow or is this okay?
Oh, this is fine.
Okay. So du equals
2 dx. Right.
Yep. So go ahead and plug in. Note that there's no like 2 on the left side. There's no 2 right here. So I have to get so I'm going to plug in 1/2 du in place for dx. I just like noting like what I'm substituting in. Cool. And then this guy is going to be my u. Look at that. I have 2 different color of highlights. Okay. So this will be 1/2 integral secant squared u du. It's equal to 1/2 tangent of u. So when we plug in, just plug back in u. We have 1/2 tangent of, let's see, 2x minus 1 plus c. Done.
Right down.
That was a nice one.
Ah.
So this is another U substitution. So did I space it out for you? Yeah, I spaced it out more. Cool. Try to give you guys enough room to write. Also, it's hard for me to write. So cosine to the 4th x sine x dx. This is fun. All right, let's do some U substitution. So I'm going to let U equal what? What do you think, Bradley?
Sine x.
So
that when it's du, it's cosine.
I could do that. Yeah, honestly, either way, it doesn't matter here. I'm just going to let U equal cosine x.
Wow, I forgot you were.
Because when I do that way, I'll have, because cosine is to the 4th power, and the derivative of cosine deals with sine, so I'll knock out the sine, and then I'll just have u to the 4th. Yeah.
Okay.
Because the only reason I do that is because cosine is the one with the exponent. Okay, well, yeah. I try to make things as easy as possible for myself. So du is going to equal negative sine dx. I'm sorry, negative sine of x dx. That way this guy is knocked out, and then I'll just have u to the 4th. Let's see.
And do we plug in?
I could change the bounds because that would make it easier.
Yeah.
So I'll say u of 0, so plug that in,
It's 1.
and then u of pi over 3
is 1/2.
Let's see, pi over 3 is 60, cosine 60 is 1/2, yeah. Cool. I just had to look at the triangle in my head. All right, so we changed the bounds, which means we don't have to plug u back in at the end. We can just straight up evaluate it with these bounds. So don't forget I have this negative sign with du. This guy right here has to be included with du since it's not in the original part, in the original equation. Whew. All right, so I have negative bounds from 1 to 1/2
I didn't know.
u to the 4th du. Well, guess what? If I flip the bounds, because I'm going from like a big number to a smaller,
Negative.
right? Get rid of the negative, because then I have two negatives that cancel out. Sweet. 1/2 to 1 of u to the 4th du. Tricky trick. All right. So that's equal to u to the 5th over 5 from 1/2 to 1. Chilling. All right. So 1 to the 5th over 5 minus 1/2 to the 5th over 5.
Oh,
Sorry. So it's 1/5 minus 1/60th.
no, I got 5 over 32.
Oh, sorry. Over 1/60th. Because 1 over 32 divided by 5.
1 over 32 divided by 5. So it's going to be 5 over 32.
So it's 1 over 5 times 32.
Um,
Because you have 1 over 32 divided by 5.
so you multiply by.
Yeah.
Yeah. Okay.
Alright, so
The other way.
this is really ugly. Let's see. Oh, so this is going to be 32 1/60ths. Just multiply by 32 over 32.
32.
Because 32 times 5 is 160. Because to get the 160 in the first place, hold on, I'll back up a sec. Okay. Oops. So,
Yeah.
because yeah, I have 1/5 minus 1 over 32 over 5. And so I can simplify this. Because 1 over 32 divided by 5 is the same thing as multiplying by the reciprocal, which gives 1 over 160. So since I changed the right denominator, I have to change the left. Well, I see that when I have 1/5, oh cool, multiply by 32 to get the same. So 32 1/60th minus 1 1/60th is, yeah, 31 over 160.
Wow.
Yeah.
You don't give us anything to the 5th.
Ever.
Yeah.
Oh, okay, yeah, tell me how to do my job, Bradley. No, I don't know.
Okay. I mean, if you could keep it below like a solid 3rd, I'd appreciate it.
Mean cube.
Euler.
I mean,
Yeah, this is where I got stuff from that stuff. Because I don't remember.
So you're doing a linearization, and another linearization, another linearization.
Yeah, but like, I don't remember the equation.
Okay.
Let me see if I remember. I definitely don't remember.
Oh, I so remember.
Do it.
It's y of or f of x, right, equals, yeah, you just do it. Which is the slope times the x minus a.
Yep.
Read it.
It's linearization, but then once we do one, remember how like our current x will turn into the a because it's our starting point when we do the linearization again. So welcome to BC, where before we did things once, but now we do them over and over and over and over again. Repetition, recursive. All right. So let's do the first one. So let's see. Approximate the value of 2.6 given the derivative. Let's see. We know the initial value, so we're going to start at 2 using increments of 0.2 and go to 2.6. Awesome. So for this first one, my a is going to be 2, my x is going to be 2.2, and my delta x is going to be 0.2. This is delta x. All right. So I have f of 2.2 is equal to f of 2 plus f prime of 2 times 0.2. Yeah. So I just did x minus a because that's literally going to be our step size. We're going to have the same step size every time. So I'm just going to put 0.2 in place for x minus a. Cool. Save myself a little bit of space. Let's see. So evaluate the function evaluated at 2. Well, we know that's 0. It gave us to up here, starting point. Plus, we have to fill in, 2 times 2 minus 0, because this is my f prime of a, and then times 0.2. Whoa, I'm running out of room. Let's see. So it's going to equal 0.8.
What? I'm almost done.
So I got an answer of 0.8.
Okay.
Cool. All right. So now recursive, here we go again. So f of 2.4 is what I'm going to do. So now my a is the value, like, is the number I just did, so the 2.2. And my x is going to be 2.4, and my step size is still going to be 0.2. So I'm going to do each step in a new color so you can see it. So that's f of 2.2 plus f prime of 2.2 times 0.2. So we know the value of 2.2 because we just found it, right? It's going to be that 0.8 plus f prime of 2.2, so we have 2 times 2.2 minus my y value 0.8 times the step size 0.2. Whew. 1.52?
Which one?
Yep. Okay. And then we have our last step because we are trying to evaluate at 2.6. So this is our last step. This is the one we're really trying to get to. So 2.6. Do you don't have your calculator?
He doesn't.
Daniel. Okay. F of 2.4 plus f prime of 2.4 times the step size of 0.2. This is equal to, let's see, I know the value of 2.4, it's 1.52, that's what I just found, plus f prime of 2.4, oops, 2 times 2.4, oops, minus the y value, which is 1.52, times the step size, so that's going to equal 2.176. Solution. Is this what you got?
I don't know. I wasn't able to.
Oh.
I didn't have to calculate it. But I set it up that way.
Okay, cool. Just make sure my sleep deprived brain did it right.
Yeah, I got up until.
Why are you sleep deprived?
You know, yeah,
It's just the normal not sleeping thing.
yeah, you know, sleep out in the weekends. Don't sleep during the week.
Obviously. Wait, hold on.
I'm just gonna skip this.
So this one's not too bad. You only do 2 iterations.
That's true.
So try the next one. I'll start in like 10 seconds.
Calculus method. Sounds like a tablet.
I want to answer your question earlier, Bradley. So the slope field from number like 1 through 3,
Yeah.
it only depended on x because we had 3x squared minus 2. Where here, these two derivatives depend on y.
Yeah.
And so
No, I get
that's
that
when it'd be
now.
different. Sorry, I just thought of that now. I was like, oh, I should make sure to point that out.
Oh yeah, thank you. No, I understand that now.
All right, let's hit it. I forgot I was recording. Poor Louie. I just sit there for like 20 seconds.
Well, you're coming with us.
Yeah. All right. So do I need to rewrite the equation or we know what we're doing?
We're pretty good.
F prime of x equals whatever. I'll just do it. I already started.
I'll solve this when I have my calculator. I'll watch this really fast.
So check it out. We have a uniform step size because normally our delta x is equal to x minus a, but if we're doing the same step size every time, we're chilling. All right, so first we're gonna start with a equals 1. I'm trying to go to 0.8, and so but I only can increment by 0.1. So here my x is gonna be 0.9, and my delta x, oh my god, my delta x is negative, right? So negative 0.1. F of 0.9 is equal to f of 1 plus f prime of 1 times delta x. So that's going to equal, let's see, f prime of 1, we are told, sorry, the value at 1, we know that's equal to 2, plus, let's see, the derivative is x minus y, so it's going to be 1 minus 2, and times our increment, so negative 0.1. Check it out, these two negatives right here are going to cancel out, because 1 minus 2 is negative 1, times the negative 0.1, so we have 2 plus negative 1 times negative 0.1. So this is going to equal 2.1. Cool. Now I want to do, oops, f of 0.8. Hey, this is the one we're actually trying to solve for. Nice, only 2 iterations. My a value here is 0.9. Let's see, my x is going to be 0.8. Step size 0.1 negative f of 8, oops, 0.9 plus f prime of 0.9 times delta x. So it's equal to, what the, oh my gosh, 2.1 times, let's see, x minus a, 0. I'm sorry, x minus y, 0.9 minus 2.1. Oops. Is it 2.2 or 2.1? Let me think. 2.2. Yeah. Oh yeah, I see. 0.22. Cool. So that should be it.
So on my calculator, I did it. Oh, maybe is it? Oh, it's 1.2. Oh, because we used 9.
Uh-huh.
Gotcha. Cool.
Nice. All right, we're done. Number 8. 1, 2. Okay, last 2 problems. So, oh, 3. Last 3 problems. All right. Integration by parts or tabular method. Whoop, whoop, whoop. Okay.
So excited.
So let's think. It's basically the same thing. Tabular method is integration by parts. If we see that it's going to be like multiple iterations, like a lot, we're going to use tabular method, especially if one of them is super easy to derive all the way down to 0, and the other one's super easy to integrate multiple times.
Like this one.
This is a great candidate for tabular.
I did the
Tabular method?
no.
Oh dear.
I did the whole thing.
Wow. Oof. Oh gosh. Oh gosh. Okay. Whew. What does your paper look like? I'm glad I gave you more space.
What a mess.
Like messier than my notes.
Yikes.
That's saying something.
Yikes.
Brutal.
Yikes. Oof. Okay.
Good job. Putting in an extra commitment.
So remember, f of x is you want to differentiate it to 0, and g of x you're just going to keep integrating it. Super easy. Keep going. So which one should be our f of x?
Oh, tabular because it's a table.
Haha.
Oh my god.
So let me have f of x equal x squared minus 3, because if I derive that, it's going to be 2x. One more time, 2. One more time, last time, 0. Okay. My g of x is going to be e to the negative x.
The next one.
What's the integral of that?
Negative e to the negative x.
Blessed. What's the integral of that?
E to the negative x.
What about the next one?
Negative e to the negative x.
Sweet. All right, now's the time for the magic. Plus. Minus plus. Okay. So we have, let's see, x squared minus 3. Let's see. Times, well, there's a negative sign up front, so it's going to be negative e to negative x. And then I'm going to be subtracting 2x e to the negative x. And then I'm going to be adding, but there's a stupid negative sign out front, so it's going to be minus 2e to the negative x. Don't forget your plus c. So literally all 3 of our signs are negative.
Yes.
Okay. So that's where the tabular method comes from, is if you're going to have to go over and over again, like save yourself some time, especially if it's like, you can kind of like see it's going to happen, where this next one, e to the 2x, cosine x.
You can take out the e to the negative x, right?
Yeah, you could. You could take out negative e to the negative x.
Oh, what about the c though?
What about the c? So you have negative e to negative x of x squared minus 3 minus 2x minus 2 plus c. I think you write that way.
Wouldn't
We don't have initial values, so we have to leave it as plus c.
you don't get rid of the negative? You don't divide it by negative e to the negative x?
Why would I do that?
I don't know. It's just that if you're taking out of every
I don't have it equal to anything. I can't move it to the other side.
So Brian, can't you use tabular method for everything just to make it super easy, and then at the last step just like not use tabular method and then move it over and then like that just seems so much easier.
Yeah, I suppose.
Oh, wouldn't if you take out the negative e to the negative x, wouldn't all of that be a plus?
Oh.
Like we could do this one tabular and then just at the end know that after 2 like changes we know it's
No, because
e to the 2x cosine x, and we put that in the integral and move it over, right?
No, because you'd never get rid of either of them.
So you wouldn't.
You don't get rid of you don't get rid of either one.
I know, but you know when to stop because it's only two
Why?
integration by parts.
How do you know that?
Because then the sign flips and then it's the same thing as it was on the other side.
So it's an unknown integral problem. I'd prefer. So you recognizing the fact that you only have to do it twice, I mean, that's when you can use the shortcut. I guess it would be okay. Because you realize like, oh, I'm only going to do it twice.
Yeah.
But if you didn't realize that, and you're doing tabular, it'd go on forever, as Bradley said.
Mm-hmm.
So you just have to be cognizant of the fact that if you use tabular method, know when to stop if it doesn't stop.
Why would you stop at 2 though?
Because the sign changes. With trig, it's always 2.
Yeah.
Because like you go, you probably explain this better than I.
Right, because if we have e to the x as the one that we're differentiating, because that's super chill to differentiate, you're just going to be adding a 2 on the front coefficient, multiplying by 2. And then if you're going to be integrating, cosine x is the one that's always going to be integrating. It goes cosine x, and then it'll be sine x, integrated again. It's negative cosine x. You just put the negative out front of the integral, and then you have the integral you started with.
Okay.
Yeah. So
How would that look like though with tabular method?
So really, like your tabular method, you only really want to use it when one of them goes to 0.
When this stuff would work. Okay.
I just want to make sure that you know how to do the like unknown integral for your
I
test.
did it here.
Huh?
I did it here.
You did it right there?
Like for number 8. Remember?
Oh, okay.
But yeah, I'll just do it again.
All right.
It's fine.
It's just hard because you can't always recognize when to stop with tabular. Where if one of them doesn't go to 0, that's why tabular is really like, okay, cool. One goes to 0. I know that's where my stopping point is, so I know when to end. Especially when you're stressed or like taking a test that's timed, you want to make things as easy as possible. So kind of like sticking with rules that always work. But you're not wrong. You could use it. All right, number 9.
Just tricks 2 times.
Yeah, so once you actually understand at a basic level the tricks, beautiful. Number 9, okay. So integration by parts. So we'll have u equal something and dv. So let's just write integration by parts. So u dv, oh my god, so ugly. dv equals u times v minus, you guys can't read my v's and u's, can you?
No, it's fine.
Ugh.
I just couldn't yesterday. Today's a different day.
U dv equals u v minus v du.
Do you think it's
integral.
easier to write zoomed in and like
Yeah.
smaller and it's more clear?
Well, because then check out how much nicer it is.
Yeah, it is.
Versus when I had it zoomed out and I was writing dv right there. Because it's hard because you're going to be like,
Oh, does it
writing?
zoom in on your screen too?
yeah, it zooms in so I can write a little bigger and it's
Oh,
much more
okay,
clear.
okay.
Yeah.
I thought it
Alright.
just zoomed in for us.
No.
Wow, it's like talented.
It's much, much easier to write this way. Okay, so I can write much clearer. See, I found out the trick. So I'm gonna let u equal e to the 2x because that's pretty easy to differentiate. So du is just gonna be 2 e to the 2x. dv is going to equal cosine x dx. So when I integrate that, v is going to equal sine of x. Okay, cool. So let's just go ahead, plug into the general formula. E to the 2x cosine x dx equal to u times v. So e to the 2x times v of sine x minus the integral of v sine x du, which is 2 e to the 2x, forgot to put that there, dx. So this 2 can go out front because you're like multiplying it. Maybe I should do that another color. So that 2 can go out front. Okay,
Did you
Here-
start the screencast again?
I never stopped it.
Oh, cool.
Yeah, so there's like a minute where there's silence.
So
You guys are
Louis-
working.
So Louis can just
Try to work along with us.
whole story. Just knows everything.
Because if you guys ask me questions, I want to make sure I don't forget to start it again.
Yeah, sure. That's
Okay.
2 minutes of upload time.
It is about load of upload time. Okay, cool. So let me just rewrite this real quick. So e to the 2x, that way I know exactly what my integral is going to be this next time. Minus 2 integral sine x e to the 2x dx. Okay, so once again we have this like unknown integral. We have no idea what it's going to equal, this guy. So I'm going to do integration by parts again. Since it's an unknown integral, you do integration by parts twice, and then you like will end up with the original unknown integral on your right side. Move it over to the left. You're done. So we gotta do a u and a dv again. I'm gonna let my u. So remember, you can't switch halfway. So originally my u was e to the 2x, so I have to keep that. Otherwise, I'm gonna be undoing all of my previous work. So du equals 2 e to the 2x dx. V is equal to negative cosine x. Go ahead, plug that in. Oh my god. I gave you guys room, but clearly not enough. Okay, so I just copied over my original stuff. Alright, so U times V. So that's, well, I'll have a negative in front of the cosine. E 2x cosine x minus the integral v du. So negative cosine x times 2e to the 2x dx. Yeah, this is a buttload of work. Okay. Let's see. Yikes. So here, these guys cancel each other out, so I'm going to make those positives. Those negatives cancel out. So make them positive. Whew. And then I have to make sure to distribute out the negative that's out front. So when I distribute out the negative 2, ugh. Let me just write 2x sine x. Distribute it here. So plus negative 2 times negative e to the 2x. Right here.
No. The gray.
These two? Because there's a negative out front.
I
Yeah.
didn't see it.
So I corrected that inside the parentheses before I distribute the one outside. Because honestly, like, it's the whole negative thing. That's the small mistakes you guys can really avoid if you are meticulous with your signs.
I almost just ran into that exact same problem. Like, basically at the same time. That was really stupid.
2 cosine x. Oops. Let me pull the 2 out front. Sorry, I forgot about this 2 guy. That should go out front here. So I pull it out front.
What else we wouldn't have?
Right, so then I have, oops. I'm just trying to do it in like one step so I don't run out of room. So minus 4 integral cosine x e to the 2x dx. Because I'm really trying to make sure that this guy matches my original, which now it does.
Wait, why do we have 4?
Because the negative 2 right here and the positive 2 here. I pulled this 2 out in front. Yeah.
Distribute the original 2 too?
Yeah.
I just left it on the outside.
Well, I mean, no, you have to distribute it. Otherwise your numbers, your coefficients will be wrong when you move this guy to their side. Okay, so my original integral is right here.
But do you have to
On the left
distribute
side?
the negative?
Yeah, I distributed the negative. So here, these negatives turn to a positive. This negative turns to a negative.
So it's minus 4. Okay,
Yep.
cool. Okay.
Cool. Okay, so this is my original integral. Here over here is, I'm still having it equal my original integral. So what I'm going to do is add 4 on both sides. Add 4 of my original integral. Add 4 cosine x e to the 2x dx. Plus 4, oh gosh, I'm running out of room. Will you understand if I like, right, it's the same thing. You see I'm adding 4 on both sides.
Understand.
Huh?
We understand.
Okay, cool. I appreciate that. Okay, so now I have 5 times my original integral of e to the 2x cosine x dx on my left side. That's equal to, whew, all right. I feel like you guys see what's coming. Plus 2e to the x cosine x. Boom, done.
And you can take out the e to the. Oh no, you can't.
I mean, you can, because it's on both. You can take out the e to the, oh wait, shoot, that should be a 2. Ah!
I have
You
a
can't.
disgusting feeling that you're gonna have this kind of problem, but you're gonna have points too, so we're gonna have to plug it all
But hopefully it'll be nice points.
in. I hope so.
0 and 0, please. Then.
Okay, so let's please the Bradley. E to the 2x So I'm pulling that out. Alright, sine of x plus 2 cosine of x all over 5, and then add c to that. Woohoo! Unknown integrals!
So what happened to the 4? Oh, never mind.
Yep, I added it to the other side. Total of 5 divided by 5. Okay, so this is our last one.
That's
we have 7 more minutes. We're good. Yeah, sorry. Yay.
Yay. Wait. Oh, you didn't? Okay. But I can just, I don't have to write equals. Like, I don't have to write the original equation.
No, it's
That
fine.
takes up a lot of space.
It does.
This alone takes up a good amount of space. I couldn't imagine trying to calculate this and
Brad,
wolf
Brad,
on
you
alpha.
ready for Tiffy Mob?
No. Are you? I didn't think so.
You gonna get fire starter, Brad?
I don't think I am.
You actually let me know when your shots are, so I actually go watch them.
Mine's on the
Oh
senior
god,
shop
mine
until-
is coming up in like 3 weeks.
Alright, let's do number 10.
Well, send her an email so she remembers.
It's
okay?
literally 3 weeks from now. The 26th. You want us to do it?
Tabular method. Thank God.
Well, no.
Yes. No, not tabular.
You can't deal with ln of x.
What are you gonna do? Derive ln of x? It doesn't go to 0.
What?
What are you using for your f of x and g of x? Because x cubed, if you derive that, you can get to 0, but you can't integrate ln of
Start
x.
doing the integral of ln.
Yeah, remember how we did integral of ln x yesterday? That was the pain in the tuchus.
Wish I didn't.
Okay. Yeah, because we can't integrate ln of x, we literally had to do integration by parts just for the integral of ln of x to dx. Whew, alright, so we gotta do integration by parts for reals. How about u equal ln of x?
Can we just not have class Monday?
We don't. We never have class on Monday.
We haven't had a Monday, so I wouldn't know.
We had one Monday. Well, because you think about it, Tuesdays, I see you guys. Wednesdays, Thursdays, every other week, and Friday. So the 4 days a week. Yeah, which is one reason why I was like, oh yeah, we could have our 0 period on Monday because that's a day we don't normally have class.
We'll have class every day. Right?
I'd like having it on Tuesday.
But Tuesday's nice to have an extended period,
Yeah,
especially to give you guys like real time for tests.
it's much nicer.
Okay, so ln of x, I know du is just 1 over x dx.
So
And I'm gonna let dv equal x cubed dx. Because I can't integrate ln of x, so it has to be the one I'm taking derivative.
Well, I mean, we know
Driving.
now.
Well, yeah, it is x ln x minus x. Okay, let's
And then
drive.
it's just gonna
Let's
keep going.
integrate that.
Yeah.
It's so ugly. It's so ugly. It's horrible.
Yeah. Okay.
All right, so v is
Trust
equal
you.
to x. It is because
Oh yeah, because product rule.
yeah, man.
Oh, no.
X to the 4 over. Yeah,
That's
it's
so
like, what are you
bad.
thinking of?
That's so bad.
People look in, they're like, what are you talking about? Integrating ln of x.
Just crying.
Finding the second integral.
Oh my god, who
Mr.
are.
Headless just class walks in like freshman. Like, all right,
Sometimes,
I'm dropping out of high school.
like
They walk in. they
sometimes
see
I
us
close
crying.
I tab my tablet and I go to other class and I'm like, what is that? I'm like, oh, let me pull up your stuff.
Oh, did they say what is that?
Uh-huh.
Mr. Brian,
Huh?
can you imagine that, like, just a freshman come in and we're just crying as we saw this
Oh.
map?
And they just look at the.
Yeah.
I think it's funnier if we're just like doing our thing and they walk in and just see that on the board.
Yeah. No, it's much better if we're just crying as we do it.
Alright, I just wrote the general formula. I really want to finish this for in a class. Let's see. So u times v, so that's ln of x. No, we can do it. Do anything you set your mind to. Alright, x to the 4 over 4.
Times them?
Huh? U times v. U times v.
I was talking
Multiply.
about like with a time limit you can do anything. But...
Oh, yeah, why not?
Let's go with that.
X to the 4 over 4 times du, which is 1 over x dx.
So that just cancels.
Right? Yeah, you can
Yeah,
do it.
x to the 4 over 4, ln of x, minus integral, x to the cubed over 4 dx.
Should we bring it out too?
Huh?
Should we bring out 1 over
Oh,
4?
yeah, you should. Yep. Okay, so let me bring it out to keep going. Oh my god, I can't write.
This makes it much nicer.
Oh, now we can just use tabular.
What?
Wait. Oh no, it's just yeah.
No, you don't need to do anything.
Yeah, we're chilling. X to the 4 over 4, ln of x minus 1/4. The integral of x to the cubed is just multiply, let's see, it's just x4 over 4. So you're doing this whole thing, x to the 4 over 4, ln of x minus x to the 4th over 16 from 1 to e. So it's going to be e to the 4 over 4 minus e to the 4 over 16. Yeah. 0 minus 1/16.
What about the ln?
No, so ln of e is just 1, so multiplied by 1. ln of 1 is 0. Yeah.
Minus 0. Or no, it would be minus 1 over 16, right?
Yeah. Because with e, yeah.
That makes sense. So can we just leave it in that form?
No.
Here then.
Nice try. We're almost done.
Oh, we
So
have
to get the same on the bottom, yeah, and this guy just goes away. Negatives here go to a positive. So we have 4 e to the 4 minus e to the 4 plus 1 all over 16. Simplify that guy. It goes to 3 e to the 4 plus 1 over 16. Done.
You're right about the power of the mind.
Yeah, man.
Do anything.
It's equal to about 10.2996. There you go.
Oh.
Dunzo.